Hello students, now we will be discussing another non-parametric test which is called Mann-Whitney U-test. The use of Mann-Whitney U-test is to compare two sample means that come from the same population. Okay, to test whether two sample means are equal. In parametric test, for this purpose you can use an independent t-test, but if it is a non-parametric test, you have to go with Mann-Whitney U-test. Let's discuss the concept with an example. Okay, so you have a question here. In this table, given the results of an experiment score for treatment A and B by 6 people. So you have to find if there is any difference between the rank of each treatment. Significance level for the test is 0.05. So these are the given data. Using this, you have to solve the problem. So we have the hypothesis here. The H0, the null hypothesis, states that there is no difference between the rank of each treatment, and the alternate hypothesis is there is a difference between the rank of each treatment. Okay, so here to solve the problem you need to identify the U statistic. So the formula for U statistic is given as U equal to N1 N2 plus N1 into N1 plus 1 divided by 2 minus R1. Okay, that will be U1, and you also need to find out U2, which is equal to N1 N2 plus N2 into N2 plus 1 divided by 2 minus R2. Okay, so the N1 refers to the number of elements in the first column, which is 6. Okay, N2 refers to the number of elements in the second column. In this case, that's also equal to 6. Okay, and now we need to find rank 1, R1 and R2. For that, you have to rank these elements. Okay, altogether we have how many elements? We have 12 elements. So we have to write the rank from 1 to 12. So I have already enlisted the rank 1 to 12 here. Okay, now the least valued element, that should be given the rank 1, and the next highest should be given 2, 3, and the highest value in the table should be given the highest rank, in our case 12. Okay, and you can see that some numbers are repeating, like 2, we have 2 2's, right? Here also we have 1 5, here also we have 1 5. Okay, basically we are taking all these elements together and arranging it in an ascending order. Okay, so we have arranged that in an ascending order here and assigned rank 1 to 12. Okay, so here you can see we have 2 2's. Okay, here 2 5, 2 6, like that. So if there are more than one elements corresponding to one particular rank, you have to take the average of that rank. Okay, here we have two variables corresponding to rank 1 and 2. So we have to take the average of this, average of 2 plus 1, which is 3 by 2 equal to 1.5. So we have to assign this value of 1.5 to 2. Okay, likewise for 5 also you have to take the average of rank 6 and rank 5, which is 5.5. Okay, and now you have to mark that rank alongside of your values. Okay, so here here my first element is 3. The rank of 3 is 3 itself. So I am writing 3 here. Okay, so 4 the rank is 4 itself. writing that here. Now the next element here is 2. The rank of 2 is 1.5, right? And 6, the rank is 7. Okay, and again we have 2, the rank of 2 is 1.5. And then we have the element 5. 5 is having the rank 5.5. Okay, and here also you have to find the ranking and write it here. Okay, see, 4.9, the rank is 11. 4.7, the rank is 5, right? And 4.10, the rank is 12. 4.6, the rank is 7. 4.8, the rank is 10. Okay, so now we have added the ranks here, right? Now take the sum of this ranking and write it here, and here also take the sum of the rank and write it here. Okay, so our R1 is 23 and R2 is 55. Now we have all the values needed to solve this U statistic. Okay, N1 and N2, in our case both these numbers are equal to 6, and here we have R1 as 23. Okay, and first you need to identify U1 by substituting these values. Here the result for U1 as you can see is 34. Okay, now you can find the U2 by substituting the values. The U2, the calculated value for U2 is 2, right? So your U statistic here will be the lowest of U1 and U2. Okay, so U1 is 34, U2 is 2. So U statistic for this particular problem will be 2. Okay, and now we have to compare this U statistic with the table value. So as discussed, our alpha value is 0.05. Okay, and this is a two-tailed test. This is the table of values for Mann-Whitney problems. So you have to check for N1. Our N1 is 6, N2 is also 6. Find out the point where these two intersects. This is the point where N1 intersects with N2, right? So here our value is 5. You need to compare the U statistic with U critical, which is equal to 5, right? So as the table value is greater than the calculated value, you need to accept the null hypothesis. Okay, so in this case we have to accept the null hypothesis that there is no difference between the rank of each treatment.